Continue on chapter 5, function and graph. 5.1 functions. These are the learning outcome for these subtopics. Cubic functions. Step for sketching cubic graph. First, we need shapes. There are two types of cubic. First, function when there are only x cubed in the function. So for positive x cubed, and start from below above, and then negative x cubed, start from above to downwards. The other one when 3x in the when there are x in the function, x times x times x. So this is a positive graph. Again, start from below and above. The other one, negative x. So start from above to downwards. Okay, so for positive graph, always be upward, positive, and for negative graph, it's going below, going down. And then sketch graph, intercept and domain. The same thing, x equal to 0, y equal to 0. Both fx equal to 3x cubed plus 1. So there's only x cubed in the graph. So this is linear type of graph. And then positive x cubed, so graph will be upwards. First shapes, and then sketch graph, intercept and domain. When x equal to 0, y equal to 1, and when y equal to 0, x equal to negative 0.69. And then sketch graph. Shapes going upward, so x equal to 0, y equal to 1. Yeah, and then y equal to 0, x equal to negative 0. And then graph. And then label the graph. Fx equal to 3x cubed plus 1. Next examples, fx equal to negative x times x minus 2 squared. So there's one x here and x squared here. This is a cubic graph. Then shape, since there are two x in the graph, x times x, so shape will be the second one, and negative x, so going downwards. Yeah, s. And then sketch graph, intercept and domain. When x equal to 0, y equal to 0. And when y equal to 0, x equal 0 and 2. Sketch graph 0 and 0, 0 and 2. Yeah. And then shape from above to up. But there are only two intercepts in the domain, so look at the function. X is linear, x minus 2 is quadratic, so there are minimum point or maximum point in this function x minus 2. So for x equal to 0, graph is going downwards, and then quadratic at x equal to 2. And then quadratic at x equal to, and then label the graph. Fx equal to negative x, x minus 2 square. Next function, fx equal to negative x cubed plus 4x. So there are x in the graph, means shapes is the second one. fx equal to negative x cubed plus 4x. We'll simplify the function x square minus 4. So negative x minus 2, and x plus 2. There are 3 x in the graph, so shape is negative. Then going downwards. Sketch graph, intercept and domain. Y equal to 0, x equal to 0, negative 2 and 2. Sketch graph, 0, negative 2 and 2. From here, going up and then below. Label the graph. Fx equal to negative x cubed plus 4x. Last example, x minus 2 times x plus 1 times x minus 1. Then shape of graph, x is positive, so going up. And then sketch graph, intercept and domain. Y equal to 0, x equal to negative 1 and 1. Sketch graph, negative 1, 1 and 2. Fx equal to x minus 2, x plus 1, x minus 1. When x equal to 0, y equal to 2. Next function is piecewise function. Sketch a piecewise function, just follow the steps for previous graph. Fx equal to 2 for x greater or equal 0, and fx equal to 1 minus x for x less than 0. Means there are two functions in this graph. First, fx equal to 2. Fx equal to 2 is a constant function. And then second, fx equal 1 minus x. 1 minus x is a linear graph. So for a linear graph, we need 2 points. X equal to 0. When x equal to 0, y equal to 1. And the other point, x less than 0. So we need the other point in the domain, say negative 1. So when x equal negative 1, y equal to 2. And then sketch graph. First, fx equal to 2. Here included 2 for x greater than 0. And then second, fx equal 1 minus x. When x equal to 0, y equal to 1. Not included 0. And then the other one, x equal negative 1, y equal to 2. And then linear graph, straight line, connect these 2 points, 1 minus x. So this is fx. Piecewise function. Two graphs on the same axis. In second example, fx equal to x plus 4 for x greater or equal negative 2, and fx equal 3 minus 4x for x less than 2. First, fx equal to 2x plus 4, we need 2 points. X greater or equal negative 2, so need the domain negative 2, and then the other one will be 0. X equal negative, y equal to 0. And when x equal to 0, y equal to 4. Then the other one, fx equal to 3 minus 4x, also linear, we need 2 points. 2, and the other point less than negative 2 is negative 3 in the domain. So when x equal negative 2, y equal 11, negative 3, y equal to 15. Then sketch graph. For first line, 2x plus 4, x equal negative 2, 0, included, and then x equal to 0, y equal to 4. Straight line, the other one, x equal negative 2, y equal 11, not included, and then x equal negative 3 is equal to 15. Then connect these two lines, linear. And here is negative 2. The two graphs cannot be. Next example, fx equal to x minus 2 square for x greater or equal to, and fx equal to 2x for x less than 2. Okay, for the first function, x minus 2 square is a quadratic graph. So for quadratic graph, first we need a shape, smile graph, and then maximum or minimum point. Since this is a completing the square, so x equal to, and constant is 0, and then sketch graph. Next function is linear graph, 2x, so x equal to, domain is 2, and x equal to 0 and 2. When x equal to 0, y equal to 0. When x equal to 2, y equal 4. And then sketch graph. First function, one point is 2, 0. Here is included 2. And then shape is smile graph, but the domain start at 2, so start at 2 to infinity. And then second graph, 2x, when x equal to 0, y equal to 0 here, and when x equal to 2, y equal to 4, not included. So connect these 2 points, fx. And these are your exercises. Please submit the exercises at the end of lecture.